Now for the somatic nervous system, you're also blocking your afferent and your efferent nerve fibers as they traverse these nerve roots. I'll show you some of these different fibers. You have pain and temperature C fibers, which are carrying slow, dull pain information. So they'll enter. You have other pain fibers, which sense pain and temperature but are A delta fibers. So these are fast and help you detect localized pain and sharp pain. And you have specialized mechanoreceptors, which use A beta fibers. These are relatively thicker fibers. Innervating your muscle, you have A alpha fibers, which send proprioception information. And these are afferents as well, because they help you perceive where your limbs are. And for motor fibers, you have A alpha and A gamma fibers, which will leave through your ventral nerve root and arrive at your muscle tissue. It's worth noting on the topic of motor fibers, your diaphragm tends to be spared. The nerve fibers innervating your diaphragm tend to be spared because that's innervated by C3, C4, and C5. So it's very, very unlikely that you'll have a neuraxial block that goes high enough to block your diaphragm, which is why your breathing is generally not negatively affected by these neuraxial techniques. Although in someone with severely compromised respiratory status who relies on their intercostal muscles to help them expire, perhaps they could have a little bit of respiratory dysfunction associated with blockade of those nerve fibers. After blocking your sympathetic nervous system, it tends to be this pain and temperature that we block second. And finally, the motor tends to be relatively resistant to blockade. And that brings me to this concept of a differential blockade, where you can have a sympathetic block that corresponds to a different height of nerve roots than your sensory block and different than your motor block. When you deliver a local anesthetic using a neuraxial technique, you'll have some area where it's most densely concentrated, and then the further out from this, you'll have less concentration. So since the sympathetic nervous system is the most sensitive, perhaps this low concentration of local anesthetic that spreads up to this height will be sufficient to cause a sympathetic block. So you may have a sympathetic block at nerve root level T4. Then your pain and temperature may be blocked with the local anesthetic concentration that is found a little bit lower, closer to where it's most dense. And you'll only have a motor block where the concentration of the local anesthetic is the highest. So for sensory, maybe you'll have a sensory block level of T6 and then a motor block level of T8, corresponding with the sympathetics being the most sensitive, followed by sensory and motor. Another application of this differential block would be something that we use for labor epidurals, which is just to use a very low concentration of local anesthetic, something that's low enough to block the sympathetic and the sensory nerves, but not high enough concentration to block your motor. So a person in theory could still ambulate because they don't have a dense motor block. But unfortunately, you can't really get around causing a sympathetic block. Technically, light touch can be even more stubborn than a motor block to disappear. And you can rationalize this by acknowledging that the A beta fibers are your second largest type of nerve fibers, second only to the A alpha fibers. Just for sake of completeness, I'll suggest an order of nerve fiber blockade, but you will see that various sources will list these in different order, although this does seem to correlate reasonably with what you see clinically.